Hello friends, welcome to my YouTube channel. Today we will move forward to chapter number 3, which is assembly analysis with the context. So in this video, you will get to know about how to do analysis of assemblies and what is the difference between a simple part analysis and assembly analysis, and what are the contexts or connections. So we will start with our session by this example. Here you can see this plier model with the holding base plate. So in this analysis I want to apply force in this both direction, means that is a clamping force, and I want to check if I fix this top and bottom faces, means that is the touching faces of the plier and plate. If I fix that faces, then what are the stresses acting on this part, I want to check that. So for that I will go for a new study. Here you can select a static one, whatever name you want to put, you can put it. So click OK. Now here first I need to apply material. Before that, I don't want this plate to be included in this analysis, because I want to fix this bottom and plate, that is pliers top and bottom face only. So I can neglect it. So I have two options. Either I can suppress this from model, or I can exclude this from the analysis. So I will select this. So this is my flat plate. Here I will click exclude from analysis. So this plate is now excluded from the analysis. Here you can see it's not visible right now. So I will apply material here, that is a alloy steel, and I will click OK, apply and close. So material are applied to all part. Then here, if you observe in our previous session and this session, you will see this different, that is a component contact. In previous session you will see that connection tab, but below that connections tab there is a nothing like component contact or something like that. So what is these things, I will explain you. So basically component contact, if you check here, that is a bonded, it's by default bonded. Okay, before that, if you go for evaluate and go for interference detection, and if you calculate, then you can see there is no interferences there. But if you want to check the touching faces, that is coincident faces, and you can select this option, click coincident with interference, and if you calculate it, then you will come to know that which faces are touching. Now purpose of this interference detection with the treat as a coincident is that here you see the plate is again showing up. So you can simply go for a model and again go for a static part if you hide it. Okay, means it's just a representation purpose, because I am using that interference thing, that's why that is uh, plate is came up. Now here, now if you see here, that is a global contact. If you right click and edit the definition, here you will see the three contact types are there: no penetration, bonded, and allow penetration. And these contacts are basically the relation between the two components or part. Means if you see in model, then you will see there are mates for this particular part, but in SolidWorks simulation, that mates are not directly get transferred to simulation mates, the simulation connector or mates. So here you have to apply the particular contact condition as well as the connectors. So in this case, you can see by default it's a contact type is a bonded. Now there are three contact points. So what is the difference between these 3 points? First one is a no penetration. uh, if uh, if your part is uh, means, if you have these three parts, and you want to give a no penetration contact between them, then it detects, means SolidWorks simulation detects that the three are the different parts, and contacts on means contacts, when they are get in touch with each other, it will work as a no penetration, means no penetration inside it. The second one is a bonded. In bonded, it will treat all the touching faces as a glue, means bonded, or you can say as a single part. Means if you go for a bonded with a touching face, then the whole assembly, means whenever there is a touching face, it will treat that as a one face. So it will work as a single assembly and single part. Means if I go for a bonded, then all these faces are touch with each other, and it will treat this as a fixed, means welding joint, or you can say a fixed joint is there. And last one is allow predation. Allow predation is like if your part is in future, if deformation happens and that part will penetrate each other, then in such condition you can go for allow predation. Most likely means in many example you will mostly follow the bonded or no penetration contact as per your requirements. So these are the contact types in a component contact, and here you will see here global contact which is check mark, and here the plier assembly is whole selected. So if you go for a global contact, whatever touching faces are there, initially touching faces are there, are get bonded with these contacts. Means here if I select a bonded, then it will treat this as a single part. Means whenever there is a connection, it will treat as a single part. But in actual condition, your pin and these two components are working manually or related to each other. So here we will go for no penetration contact. Here friction option is there, but means if you know the friction coefficient, then you can put, otherwise it's okay. Means in actual condition, if you know the material has some friction, then you have to put it. So here I am not putting any. So here I will click OK. Now this is my global contact, and if you check here with the contact visualization plot and click calculate, then you will come to know that if this is my component contact, is whatever touching faces are there are automatically contacted with the no calculation, sorry, no penetration contact. And this option came only SolidWorks simulation premium or above. It won't come in SolidWorks simulation standard or in any CAD package. So here I will fix the geometry. I want to fix the edge, so select this again. I will delete first face and I will go for select this. Then I will apply a force on both the sides. So for that I will go for a force. I will select this edge and this edge, and here I will put 220 as my force. Here one option came up, per item or total. Whenever you select multiple faces in force or torque, this option will came up. Its per item means on both faces 220 Newton force acted. If you go for total, then it will half on either faces. So I will go for OK. So this is my 220 Newton force applied. Now I will go for a normal mesh, create mesh, curvature base, and OK. So mesh will create. Now I will run this study. It will take a little bit of time because of the contact conditions. Whenever there is a context in your assembly, it will solve that all contact constraint. Because of that, this little bit time get increased. So this is my result. Max stress is on the sharp edges. Basically that are the singularities. If you go for a singularity check, you will come to know, okay, on that faces singularity is there. If you isolate that, then you will come to know. So option is to remove that singularity, you need to apply fillet on the faces. Okay, so the result, my stress values are on 138, which is below yield. This part is the same basically. If you go for a displacement, the displacement is around 0.52 512. Basically this displacement is one side displacement. If you see here maximum displacement, it will show this edge maximum displacement, but both the edges are displaced with the same magnitude. That's why the total displacement is 0.512 into 2, means total distance covered by this this arm. So here, if you here I have created one uh, configuration, means exploded view. So you can use that exploded view and you can see the where which force acting on the particular part. So here you can see that maximum and minimum, the notations are, we can remove that. this is how the stress is acting on particular part. It's about deformation. We will go for a stress. So you can see the sharp edge corner have a little bit high stress as compared to the pin. And here if you change your stress value to yield strength, that is 620. So here in chart option, if you change your maximum to 620, I will click OK. So you can see here values are not exceeding 620, that's why it's not showing up. That's okay. Now after clicking explode review, we have to rebuild it, so it will come to Solidworks position. Okay. Now okay. What I need to do is I know here for my 220 Newton force I will get a displacement of about 0.512. That is one side. If you multiply it by 2, you will get a total displacement. So according to our first FEA assumption, means if you double the force, your displacement also get doubled. On that criteria, I need to now touch the both the faces. Basically, I need to cover the both faces should touch at this edge. I want that criteria. So for that, I will first measure what is the distance in it. So for that measure, I will select this edge and this edge. We will okay, length distance is a 15.24. So we will go for normal calculation. Okay. So here you can see this the display distance is a 15.24. So I created in calculation here my for 220 Newton force I have my displacement 0.512 from one side into 2 for both sides. So I want to calculate it for 15.24 mm displacement. What is the force needed? So for that 15.24 into 220 divided by this term. So I get 3274.21. So I directly randomize this to 3500 Newton. So I will apply this force on both the surface. So in static, I will change in original study only. So I will go for here, right click, and here I will put 3500. Now main now here you can see this after means in future these both ends going to touch each other. So I need to apply one contact set there. Means after deformation that contacts will be appear. Right now I am giving global contact which is only applied automatically to touching faces, but these faces are not initially touching. We need to create one contact set that is a global local contact, you can say it. So here you will see the contact set as a different option, and here types are no penetration, bonded, allow penetration, same as our component contact. Two more contacts are there, shrink fit and virtual wall. So shrink fit and virtual wall we will see in our next lessons. So here I will select no penetration, I will again select these two options. Sorry, in two different groups. Okay. Basically this is my source and this is my target, but here two faces are there, so you no need to remember any sequence for that. So here friction and grab clearance, this option will cover in next master assembly mode. So here basically in advance we need to select no to surface contact and click OK. By default if you check here, this option won't come automatically, this advanced option. To activate that option you need to go in simulation options, and in document option in mesh, here you need to check this option, show advanced option for contact set definition, no prediction or shift fit only. After that that option will come and you need to basically activate that option. because calculation is more accurate for surface to surface contact if there is a surface to surface contact is there. Here we have applied two faces and no to surface contact because this edge is going to touch each other in future. So I will go for a run study. Mesh is completed. Now it go for analysis solution. Here you can see the convergence plot also, means how your results are iterations are going to happen. It will show in your window, and here you can see this option, more accurate surface to surface contact but slower. Here you will get a notification that excessive displacement are calculated because you are going to see the displacement at around 15 mm, which is much more larger. So this option shows you your analysis will go, means will give accurate result or a displacement in on a large displacement mode. If you click yes, then it will automatically go to large displacement mode. But here I want to no need to go for large displacement. I need to check it in static analysis only. So I will click no. Here you can see the faces are touching each other. The stress value is I already set it to 620. So above 620 all regions you can see here. If you go for automatic, actually my default stage plot it's set up to 620, that's why you are seeing this result. But if you set to actual value, it will show these corner edges only. And if you go for a displacement plot, here you will see the displacement is around 7.69 mm. You have to multiply it by 2 because two sides the displacement is 7.69, so you will get 15 point something. So this is how you can use that assumption, and you can predict the force according to it. Now in this most important factor is a global contact and local contact. So the preference, if your part has a global context already and if you define local contact for it also, means contact set or in compound contact, if you uncheck the global contact option, then it will go automatically to local contact. So preference for your local contact is a prior, means it's on a top level, and below it global contact will come. Means if you for single part, if you give a global contact as well as local, then preference should be goes to global contact. So this is a very important factor in this, and this is how you can do a simple assembly analysis. Now in next session we will see the shrink fit option, means how to apply shrink fit and how to do analysis regarding this. And furthermore we will get one master assembly. In that you need to add all connectors, components, contacts, all things are there. So we will see in coming upcoming our upcoming videos. So hope you like it and understood the whatever explained you today. And if you get any query, kindly comment down below. And thanks for watching, and do like, share and subscribe to my YouTube channel. And also give me a feedback, or give me or you can ask me any query regarding the same. So thank you for watching. Bye.